Hey, hello, welcome to the show. It's me, John Park. It's time for John Park's Workshop. Thanks for stopping by. Thanks for coming on over today. We've got some fun stuff to look at, so I hope you enjoy. If you're interested in chatting during this, come on over to either the YouTube chat or our Discord chat. Over in the YouTube chat, hey, Dave Odessa and Beata Graf Abdelhagen, Johnny Bergdahl, hello. Thanks for popping in over there. If you're looking for our other chat, the Discord, then go to adafruit.it/Discord and look for that live broadcast chat channel. You can see it right there. My fan just kicked on. I'm going to turn that off. There we go. And you can join the likes of Andy Calloway, C. Grover, Johnny Bergdahl there as well. Hello, Paul Cutler, Thin Man, howdy. Thank you for stopping in. And let's get to it. So, what's going on in the show today? I've got a coupon code for you so you can save some money over at the Adafruit shop. I've got a recap of a product pick of the week. I have a shiny, fancy, new CircuitPython Parsec for you in the continuing series of creating a drawing program on a touchscreen. And then I wanted to do a bit of a Learn Guide recap for the DMX NeoPixel project, as well as take a little bit of a deeper dive into how that works, how I'm able to control some of the different things with just a few channels of DMX, how this little simple controller works in case you're new to that stuff. So that's the plan there. And I've got some coffee, so let's get to it. Delicious coffee. So, first of all, that is our coupon code for the week this week. It is Chaser, or for the day, I should say. And that is going to get you 10% off over in the Adafruit shop until midnight East Coast US time tonight. And what can you do with that? Well, head on over to Adafruit. That's Adafruit right there. And check out some of the new products. There's a bunch of cool new stuff. Raspberry Pi has been releasing a bunch of interesting looking things, including these new little HDMI monitors. We've got, if you look at this new products section, you can click on View All New Products. We've got skull filaments, unicorn LED filaments, snowflake filaments, aforementioned monitors, some new snap enclosures, stepper motor driver, and on and on. Some more of this Raspberry Pi 5 stuff. Unfortunately, the 500 desktop is not in stock yet, but we do have some of these pretty cool little SSDs, and there's an SSD hat you can get for that, and more, much more. So, with the coupon code, you'll get 10% off on anything in the shop that we can ship to you. It does not work for gift certificates, software, or subscriptions, but it'll work on physical goods. And if you want more, go to adafruit.com/free, and you'll see there are some enticements for spending more and more and more. So if you spend $99 or more, you get a free PCB coaster. If you spend $149 or more, you get the coaster and a KB2040 microcontroller. Perfect for keyboard projects, for gamepad projects. If you spend $199 or more, you get the coaster, the KB2040, and free continental United States UPS ground shipping. And then if you spend $299 or more, you get the coaster and the KB2040 and the free shipping in the continental United States and a Circuit Playground Express. So that's some neat free stuff you can get if you do a big bunch of shopping. Keep in mind, I don't know if it'll pop this pop-up up because I closed it, but we have some deadlines. There it is at the top. It says deadlines for ground shipping. You can check out here. UPS ground orders have to be ordered by 11 a.m. East Coast time, U.S. Tomorrow. Is that right? Yeah, Friday the 13th, Friday, December 13th. So those are some of the things about the shop there. But most importantly, save yourself some money for today until midnight. Use the Chaser coupon code to get 10% off. And what else? Someone noticed Lars is doing gymnastics. Yeah, Lars is hanging out way up there. I'm not sure what's going on with Lars. And we've got a recap of the Tuesday show next. So on Tuesdays, I do the product pick of the week show, show you a cool product from the shop, give you a big discount on it, give you a little bit of a demo. This week it was this cool feather, and I got some tattoos, and then I got them removed, and here's the recap. It is the Feather ESP32V2 with 8 megs of flash and 2 megs of PS RAM. This is a really cool board, particularly for WLED stuff. So you can use this for Arduino, CircuitPython, Whippersnapper, but a really neat use is for WLED because it's got the Wi-Fi on there, so you can talk to it remotely from things like your phone running the WLED app. There's my Feather, ESP32. Here is an 8x8 NeoPixel in a nice little case. I've got a battery, and I'm going to plug it into a Feather Proto board that allows me to connect up to those beautiful glowing NeoPixels there. You can see this is all just being sent wirelessly. I can go pick different code to send to it. Feather ESP32V2. Indeed. Indeed it is. So, let me know if you pick one up. What are you doing with yours? The other projects that I've been interested in is the ESP32. That package is the one that I used the QT to do composite video stuff. And it might be nice to do some composite video stuff on the Feather, because then you can have it battery powered and plug it into some old TVs and things, do some neat composite video. Let's see, what else? Let's jump into this CircuitPython Parsec. CircuitPython Parsec. All right, for the CircuitPython Parsec today, I'd like to show you the continuing saga of the touchscreen drawing tool running on a Pi portal here. Let me just check my focus here. Yeah, that's looking pretty crispy, right? Yeah, it looks good. Okay. So for the CircuitPython Parsec today, I want to show you how we can create a pop-up color picker for our triangle drawing and editing tool. So here you can see this is the triangle editing using Vector.io and Touch.io in CircuitPython. And you'll notice one little addition since last time is I've added a little white circle to the center of the triangle. And you can see that stays centered there wherever I move the points. And the reason I added that is I just wanted to have something I could click that's obvious, that is going to bring up a color picker so that I can change the color of the triangle. So I'm going to click on that little white circle there, and you'll see I've got now these 3 sliders, and if I go and click and drag those, I can adjust the red component, the green component, and the blue component of my triangle. And then when I'm done with that, when I want to get rid of this little pop-up, I just have a little gray box here that I can click, and that goes away. So how does all this work? This is in fact the same code we had previously as far as building the triangle portion of it and editing it. But then I have some additions. So if you look here in CircuitPython, the first thing that I'm doing that's a little different is I'm adding a center circle. So this is another vector IO circle, and that's the one that goes in the middle there, colored white. And then I am adding some new variables for keeping track of my sliders and drawing them. So I have an X and a Y position to start with and a size to start with, and then I just build on those to do those 3 sliders. And those are the rectangle, display shape rect, and then uses those values to draw those on the screen. And then I'm hiding those with the slider.hidden, 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 enter button, and the indicators, which are just these little horizontal boxes on top that are gray, so we can see where we are on top of it. So all of that right there creates those sliders and creates their indicators. And then I'm also creating a little, that little gray box. Then we have some functions here. This one updates the position of the center circle by finding the centroid of the triangle, so averaging the 3 positions and finding the middle point. That's how that little white dot stays centered there. And you can see it's pretty responsive. It updates pretty quickly using vector IO for that stuff. And then in the function check for checking to see if we're touching a circle, now not only are we using that to decide when to adjust the vertices of the triangle, but we're also using that to decide if we need to pop up the UI for color picking. So all of this is the same here. We're getting a touch point where what's the XY coordinate on screen that I'm touching. We're casting the X and Y and pressure to their own variables. And then we run that check. Are we touching one of the circles? And if it is the center circle, then we flip this state of show sliders to true. So I'm going to pop that on. You can see these pop up here. And then the drag for these is if any of these values after we've popped that up of XY touch are inside of one of those rectangles, then we start updating those values. And those are then being turned into a 24-bit color value by bitwise shifting the red all the way to the left, the green to the middle, and the blue stays on the right. So we end up with just that single value that we can change the color palette for the triangle. So right here, triangle pixel shader 0, and there you can see the red component, the green component, and the blue component all get turned into one value that gets sent over to that, and that's how it updates that color. Then when we're done, we can go ahead and click on X there, and it just sets these indicators to hidden again, hides all of that stuff. And that is it. You can repeat that as necessary. You can actually continue to adjust things if you want after you've brought that color picker on screen. It'll still be accessible, but then if you want to get it out of the way, you can go ahead and get it out of the way. And so that is how you can create a color picker that pops up for use inside of vector IO and touch display. And that is your CircuitPython Parsec.
CircuitPython Parsec.
Whoa, wrong button. Clicking wrong buttons all over the place. Andy Calloway says, JP slowly creating his own Photoshop. This is going to be slow going. We'll see how far we can get. DK asks, hi DK, over in our chat on Discord, is the code from the Parsec posted somewhere? So yes, on Friday mornings, I take this video and chop it into just however long it was, 2-minute, 3-minute one that gets posted separately, along with a blog post that has a link to the code, and that just goes into a repo that I have on GitHub. So look for that tomorrow. There's usually a blog post. Also, that goes over to Ann Barella, who puts that into the Python on Hardware weekly newsletter. So if you subscribe to that, you'll see each week's CircuitPython Parsec, as well as that link to the code shows up there. So yes, that's a good option rather than trying to look at the code. Sometimes these are short enough that you can just look at the screen and get them. This one is a bit more complicated, so that's probably a good one to check on Friday for the code for that one. Answering over in YouTube, the question I had before, Beata Avdelhagen says, I have one V2 feather with ESP Home, and I plan to do a second with Tasmota. Direct comparison. I don't know Tasmota. Is that another home automation thing? Tell me more. I'm curious. I haven't done much with home automation stuff. So ESP Home on there and Tasmota. Good uses for those. Very cool. Okay, let's see. Let's now move on over to DMX territory. So let me jump back here. And I'll head to Learn. So here in my Intro to DMX guide, I had covered the sender stuff. So that's the microcontroller sending to lights. And then added this receiving. So we're using a sort of commercial light board, little mini DJ controller style one. These are inexpensive. You can use anything up through huge thousands of dollars worth of DMX equipment that's used in theaters usually. You can also use computer to little box that converts USB to serial to DMX. So there's a lot of options there. But however you're getting your DMX over to your microcontroller, which I've got over here, we've now got code to deal with that. So we're bringing in DMX signals, which are these 512-byte messages that stream through, just constantly running through. And there are 8 bits per channel of the 512 that you can use kind of for anything you want. So in practical terms, that means that we can take something like 1 neopixel. So if you look at this top row up here, and I'm gonna switch back and forth a little bit between some cameras. Let me go to this main cam view here for a second. So if you look at just that top pixel there, if I take my controller and specify just changing one slider, I'm sending values of 0 to 255 to the hue component of that neopixel, right? So what I've broken things down into is each neopixel strip only has 2 neopixels that I'm sending info to, and then the rest are interpolated in code. And so I showed an early demo last week, but I want to go a little more in depth here. So let me set this up so you can see it all. Let's do I'm gonna float this down camera here. Let me send that over there so you can see. And I'll just adjust some camera settings for you. And let's get a little more exposure on that one. There we go. So the way I've set this up is each neopixel strip is getting a set of 8 channels. So this is strip 1, and it's going to receive channels 1 through 8. This is strip 2, 17 and up, 3, 24 and up. So right now this is considered strip 3, and I've got 4 channels here that are going to correspond to one of the neopixels, and I've got another 4 that corresponds to the other. So as you can see, what I'm considering the first neopixel right now, I've actually swapped the places of them with this last control just so that we can focus on one thing at a time. So this is the hue. This is the saturation. And this is the brightness. So that's that's 3 channels there, HSV. And then the last one is where do you appear on the strip. So the NeoPixel strip in this case has 20 individual LEDs, and I can say where do we want to put that one on there. So that's what the channels 5, 6, 7, and 8, or that multiplied by 16, or offset by 16, depending on the strip I'm using. If we look at the first 4 here, that's going to be the other NeoPixel. So same thing, hue, saturation, brightness or value, and position. Now you see what happened there in DMX terms. All I'm sending is that. The reason this can look a heck of a lot more interesting and more sophisticated without using up tons and tons of channels, and part of the reason I'm addressing this is that Lamore asked last night when I was showing this on Show and Tell, so do you have like multiple DMX universes so that you have a set of 3 or 4 channels per NeoPixel? Because right here we have 70 NeoPixels, so that each had 4 channels. This gets out of hand quickly. Instead, and the reason I'm excited about this project is since we have a microcontroller involved, I have an Arduino Uno in this case, receiving the DMX, I can then filter that and do stuff with that. So the thing I'm doing in this case is saying, okay, if I'm only editing those 2 pixels, but when they are arranged with my first pixel with a lower pixel position than my second pixel, I can do some color interpolation. So I'm interpolating between the channel for hue on the first pixel and the channel for hue on the second pixel. So if I move those together, or as close as I can, it'll just appear as a single color. That's hard to do. There we go. So if I move all those together, it sort of seems like a single color strip. As soon as I offset those from each other, we can do a gradient, essentially, or an interpolation between them. If we have fewer pixels, this should go from red to yellow to green. If I just have red and green set, if I push that second one up to purple, now we'll get red, green, purple. So we're just finding thirds on the color wheel there. If we get more pixels by me moving the pixel position, then we get that full rainbow of color. You can also do this with saturation, which looks pretty cool. So if I set these to the same color, and by the way, just the angle in my camera is making some differences there, but to the eye, those look the same. So with those set, I'm going to bring their brightness down a little bit. So those are set to the same color, opposite ends of the spectrum for position. If I start to bring just the saturation down, let's say at the end, now I'm doing a saturation shift from red to essentially white by the time it gets to the end there. If we bring those together, you'll see they're just a saturated and a desaturated version of the same hue. But as we get them further apart, you get more gradation of that. This does not take into account any kind of gamma, so there could definitely be room for improvement to do gamma shifts to make it perceptually better than just a linear interpolation will give you, but I'm not doing that in this code. So we can bring this saturation back up on those. And so that's the basics of one strip. And then you can see on my controller here, I can say, hey, let's just talk about the second strip here. So that is this set of channels, 17 through 24. So here, you can't see that one. Let me move the controller out of the way. So here you can see one end pixel hue, the other end pixel hue. Bring them to new positions, and we get this little dancing set of hearts here. So these are pretty cool. These are these sphere and heart, and I have the stars. I got all 3. I don't have that one hooked up just because I liked using this bar as the bottom one there, but these are listed in the guide. So in fact, let me go back to the guide for a second here before we go more into the DMX sender. So here we have the little controller. This is what I was just talking about here. I have 8 channels per, and they are the start hue, start saturation, start value, and then the start pixel location, and then the end version of those 4. I've got a little video there that will show you how that works. Show you the jumper settings you'll use on that little shield there, the DMX shield, and the wiring. I'm using one of these screw shield, proto screw shields to wire up the NeoPixel strips. And there it is all set up with DMX out, DMX in, so I'm receiving DMX from the controller. And then we've got a bundle here you can download. That'll give you the library file that you need for it, as well as the Arduino code. So you can download just that one file and follow the instructions for uploading that or flashing that to your Arduino. And you can use Arduino Uno or the Metro 328. This is limited to AVR with the way this is set up right now. And then little instructions for use there. So what I wanted to do now was show you what you can do, kind of some of the cool effects that you can get for free by using this kind of DMX controller. And this is, like I said, not a very sophisticated one, but it's fairly standard to be able to do picking your set of, move this up a little bit, picking your set of fixtures here. So I'm considering each one of these to be a set of 8 or 16 of these channels. So that's my first strip, second strip, third strip. You can pick them all at the same time. So if we right now just touch all of these, we can go and make them all look the same. And we can go in and set individual strips differently. So there's my bottom strip going from kind of a blue to a purple. Here's my middle strip with a full rainbow. Here's my last strip. And just set it to, how about some green, like that. And then individually adjusting any of those parameters. So that's nice for setting it. But what the power of these kinds of controllers is, they have a nice UI for going through and saving these settings as individual scenes. So I'm going to go to a bank of scenes, and I'll set my first scene that I saved was they are all a little short gradation. My second scene is just an expanded version of that. Third scene, I've gone and changed the colors, changed the colors, changed the colors, and then shortened it, and then gone back to a full gradation. So those are individual scenes that you could use in theatrical settings. You'll go cue to cue, so you'll, with a cue that's being called, you'll set your lights to something new. But for kind of fun DJ party mode with these, you can just play back that set of scenes, either in order, or you can make a chase, which will allow you to pick a new program of them out of order. So if I just go to my play button, essentially this auto, you'll see that this is now going to go from scene to scene to scene, and it interpolates the values of the sliders. So imagine if this were a motorized fader thing, you'd just see these faders dancing up and down. That's what's happening under the scenes. I can set the speed that it waits between fading to the next one, and I can set how long it takes to fade. So if I set the fade time basically to 0, it'll jump quickly from cue to cue to cue here. And then if I increase the fade time and give it a little longer between changes, oh, that's not longer. We'll get to enjoy a little more of a gradual fade between them. Now I set up a second bank that's actually a little easier to see these changes. So I'm going to switch to that. So I'll go to bank 2. And I'll stop the playback. So I'll show you bank 2 is off, just the bottom is red, just the middle is red, just the top is red, and off. So if I play those, now we can see what these pause and fade are. So what I changed from scene to scene was actually just the last pixel position. So it's really as if it's only fading up and down that channel 8 there for each of those 3. You also notice it doesn't matter what I have picked over here because I'm not controlling them directly right now. I'm just letting that play its program. The other bank that I have, I'll hit stop here and go to bank 3. I have that scene that we saw when I started the show, and that scene where I have flipped the colors. Is that it? Yeah, so I just have 2 color shifts. So with this one, since only thing I changed from scene to scene was the hue on those 2 extremes there, if I play this, when it fades, you'll just see the hue run through from basically 0 to 255 or 255 to 0. So that's what's changing on those. And another nice thing is you can see those values I mean, there's a cheapo controller, but you can see them when you move the faders there. You can see we're at 0 hue all the way to 255 hue, or 255 brightness down to 0 brightness. And you can see that pixel right there changing. It's this thing right behind me, by the way. I don't know if that was clear, but I have this my workbench camera is pointed, my main cam is pointed behind me here. So let's see, questions. This was answered, but yeah, some nice asks, is DMX typically a manual process, or could you record and play back a series of changes and updates? And I'm not a DMX expert, but this is a, typical inexpensive one, can work like this. A lot of people use software these days to set cues, and I think you can do things with a little more of a record mentality. So you can say, I'm going to record, hit record, do the timing and the values that you want to on the faders, and then hit stop, and you can save that as kind of another chase or another program. And these will also sometimes have like a microphone input, so you can have the tempo of it changing from scene to scene be based on beats per minute that it's hearing or loud sounds that it's hearing. So there's a lot of ways to integrate this into more. So let's see, that I think covers what I wanted to show with this. We can do, we can try to program one. Why don't we just try to program one for fun? So let's take all of them down, and I'll go ahead and click on the program button here. And it wants to know what bank are you programming. So we'll go to a new bank. We'll go to bank 4. And what we'll do is set the values to what we want, and then add that as a scene. So right now we have essentially a blank canvas. So why don't we do a, bring up the brightness and saturation, and we'll set the pixels to the far ends. And how about we'll do a 1, 2, 3 of them moving from right to left. So so it should look like, let's get a little, should look something like that, but we want to do 1, 2, and 3. So I will set the start position at about just one pixel lit there. Can we get just the 1? No, we're going to get 2. I don't think I have a way for it to divide that down to 1. Yeah, so we got 2 pixels there at the end. So what I'll do now is set an add to scene 1. And so it's just recorded all the sliders for 3 fixtures. Now what I'll do is only change one. Let's do the top one actually. I'll change one of them to here. Let's be a little fancier. Let's go halfway. Do I want that? I don't know if we have enough channels for that, or scenes for that. Yeah, let's do that. Okay, so we'll go here, and I'm still going to make an add for all fixtures. We could stop and check these, but we'll keep going. So now the next thing we're going to do is bring, oops, not you, you the rest of the way, and the middle one halfway. Add. What scene was that? 3. Okay. Now we're doing scene 4, so that's going to be this the rest of the way, and this part way. Add scene 4, and then the last one will be rest away there. Add scene 5. May have screwed that up, but we'll find out. So I'll stamp that in by hitting Program. We'll go to Bank 4, and now check scene 1, scene 2, scene 3, scene 4, scene 5. Hey, I got it. And again, Cheapo Controller doesn't have any way to like ping pong this or copy paste or anything, but we can play it. So we'll go to Play, and then we can tune the time. So let's make it fast. There we go. So it's its own sort of unique, weird art form of animating with DMX like this. And if you look around, there's probably some better tutorials than this online of just programming both scenes as well as chases that can be mixtures of them in other orders. But this is a nice, I think, basic use of this really inexpensive, easily available hardware that you can get to talk to things that can listen to DMX. And now that we've got NeoPixels listening to DMX, it's pretty cool. Like I've said before, this could be servo motors, stepper motors, sound stuff. You could, use this instead of MIDI to trigger your synthesizer if you wanted to, by getting the Arduino to listen to the DMX, and then you cook up what that does on the other side of it. So I'll pause that there, and then we can just jump to a scene if we like. And let's take a look at the code for that. So if I hop over to my Arduino session here, again, this is the code that's in the guide. We've looked at this before, so I probably won't go into a huge amount of depth, but let's take a look at some of the stuff you'll care about if you're using this. First of all, define number of strips. So I'm setting this by hand. I'm using 3 strips. I'm setting my pins that the NeoPixels are talking to by hand here. Let me make this a little bigger. Can I make you... Whoops. What increases the size in Arduino? Is it Shift? Not that. Oh, that's it. Okay, that's pretty good. I can get rid of this output window or shrink it down. So there we can see pins A0, 1, 2 are my data pins. Pixels per strip, or LEDs per strip, I have a 30 on the bottom and then 2 20s. And then the pixel order for color, or rather the color order, this is a GRB, and then the other 2 are BGR. And you'll know right away because, in fact, I have this set up. I showed this before. When I reset this, it will go red, green, blue on each of them. Red, green, blue. So as long as I see that order, I know that I've got the color order right for the strip. If I went and plugged in a different strip right now, it would probably not work on these 2 slots here because those are the only ones I have that have that BGR color order. Then channels per strip, I'm kind of, even though I'm only using 8, I set it to intervals of 16 because this UI of this particular controller I'm using, when I hit the fixture button, it jumps by 16, or scanners button, it jumps by 16. So you could change that if you wanted to, but you could do 512 divided by 16 of these strips with this the way it is, or if you had a different UI or you didn't mind bouncing around a little bit with the UI, you could get that down to 512 divided by 8, and you're still staying in a single DMX universe. If you had to go to more than that, you'd end up with more universes and more controllers. I don't think we can listen to multiple universes on that particular shield, but I'm not certain. Then we do some setup for our NeoPixels, do our little color test, enable the shield, and then we're grabbing all the channels, so the 512 messages that come through, and then remapping some of those values that we get, 0 to 255, to work for the particular use. So for the hue value, we go 0 to 65,535. So we have to remap the 0 to 255 we get off the controller for that. And then this is I think this is, I looked at this a little bit last week, but this is the interpolation that we're doing. I have a little linear interpolation function down here at the bottom, which takes in the start and the end and the number of steps that we're giving it for something like hue or brightness or saturation, and it's giving us all of the little table of values that we need in between them to interpolate neatly, linearly between those. So this is what gets called when it's time to figure out what every pixel in between the two that we're explicitly setting should be, and then those all get set here. So that just iterates through every pixel. And you can see it does it pretty fast. You know, we've got pretty quick control there of those, even though it's having to do all that math and send out those messages. And this has been, so if I showed this last week, it was not as condensed as this. I think I had it just copied and pasted between 2 strips. Now it'll just take in however many strips you want and handle that in the code. So yes, that is the code there. This is the guide. Go check that out if you're interested. And you know, I was talking with Todd, our friend Todd Bot there earlier. The kind of neat thing is that if you buy a commercial fixture like these ones that I was using in the first half of the guide, these have a little menu on here that lets you say what's the start number of the fixture. Is it starting on channel 1 or channel 17 or whatever, and how many channels are we going to use and for what. And that is all just baked into a little microcontroller on here. So this one can either do 4 channels, and it's going to be red, green, blue, and brightness, or it can do, I think, 7 or 8 channels, and then it still does red, green, blue, brightness, but then it has, you know, channel 6 tells it to go into a strobe mode and how fast that strobe is, and channel 7 goes into a gradient mode. So those are just sort of baked in there. You may like what you get with it, you may not, but the cool thing about adding the microcontroller and NeoPixels is that you get to decide, you get to write what that is. So you could come up with your own functions, and you could potentially reserve certain channels. If I said, oh, let's use channel 9 on this, I'm only currently using 8, but let's use channel 9 to switch into some blinking mode, or you know, take whatever I have and add onto that with a little mode selector. You could do that. So it's open for some cool experimentation, I think, if you get yourself a cheap little controller and a shield and start hacking around on that. Of course, could be very useful for holiday lighting stuff this time of year. If you're interested in doing any holiday lighting stuff, this could be a cool project. So maybe go check out the guide and get some stuff and build out a cool little DMX NeoPixel setup. All right, that I think concludes it. That's what I've got for you today. Again, I'll say if you want to go get yourself some neat stuff, let's make these greenish to match. There we go. It's too bright. Bring those way down. Ish. That's a hard color to match with this thing. Whoa, now I've broken it. Chaser. Wow, wow, wow. Chaser, that is your 10% off discount for today. That'll get you 10% off in the Adafruit shop. So head over there and check out some of the stuff. You can, by the way, in any of the Learn guides, you will see some featured products. You can go pick those up. I think this one, I need to add those NeoPixel strips to that too. On the front page, I've got listed those strips that I'm using there and the little proto wing shield there. So that's just an idea, but go check out some cool stuff to get for yourself for that discount. Discount code today, 10% off with Chaser. All right, I am gonna call it there. I think we've got possibly a deep dive with Foamy Guy tomorrow. I know Scott is traveling, so I don't think he's going to be streaming, but maybe he's going to New York, so he may be streaming from Adafruit. We'll see. Check the blog, check this place, the Discord, because often that info is there. And thank you so much for stopping by. So I will see you next week. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.